Welcome to another episode of Magnificent Conversation. Today's special guest is the 5, 12, 13 special right triangle. Similar to the 3, 4, 5, if you haven't watched the 3, 4, 5 video, check it out. Learning the 5, 12, 13 is a way to save time and energy when you're taking standardized testing. So it's just a regular triangle. You could solve it, find the sides, find the angles, just like you do any other right triangle. But if you know the 5, 12, 13 like the back of your hand, you will save so much time, because a lot of questions that are asked that involve trig are more involved than just finding the sides and the angles. So they're expecting you to recognize the 5, 12, 13 so that you're not doing the legwork of finding sides or angles. You just recognize, oh, that's a 5, 12, 13. So this side has to be whatever the missing side is. So we're going to go over the 5, 12, 13, and then we'll do some practice problems. And hopefully by the end and after you practice on your own, you will have mastered the 5, 12, 13 special right triangle. Just like any other right triangle, the longest leg is the hypotenuse. So for 5, 12, 13, which I've oriented in two different directions, 13 is always the hypotenuse. And we know the hypotenuse is the angle across from 90. So 5 and 12, the two legs have length 5 or 12. And the hypotenuse has length 13. Okay. So in this first drawing, the shorter leg would be 5. The larger leg would be 12. And again, shorter leg is 5. Longer leg is 12. Now, in a lot of questions, you might be given information about two of the sides. Instead of going through the Pythagorean theorem, which will take time, you should be able to pull a 5, 12, 13 out of a question. And I'm going to go through how you do that. Let's take a look at our first example. So we have our right triangle drawn. We know our angle theta is the one in the bottom right. So given cosine of theta is equal to 5 over 13, calculate sine of theta. Okay, so let's look at what we have, what information is given to us. So we know cosine of theta is equal to adjacent over hypotenuse, and that's 5 over 13. So I can label my hypotenuse 13, and I can label my adjacent side. So let's get our sides labeled. Let's go back across from 90, hypotenuse, across from the theta we're concerned with, opposite, next to theta, adjacent. And our adjacent side is 5. Here we go. I see my hypotenuse is 13. One of my legs is 5. That means my other leg is automatically 12. So if I want to calculate sine of theta, which is opposite over hypotenuse, I have 12 over 13. And it's that simple if you recognize the 5, 12, 13. Let's take a look at another example. We have our right triangle drawn. We know which angle we're referencing. It's the top angle. That's our theta. So given cotangent of theta is equal to 12 over 5, calculate sine squared theta. Okay, first let's label our sides. Across from theta is our opposite side. Next to theta is our adjacent side, and across from 90 is our hypotenuse. Okay, so let's look at what information we were given. Cotangent of theta is equal to adjacent over opposite, which is 12 over 5. So our adjacent side is 12. Our opposite side is 5. I know my two legs are 5 and 12, so my hypotenuse is automatically 13. And I need to calculate sine squared theta. Remember, we like to rewrite it as sine of theta squared. So we know we find sine of theta first, and then that is what we're squaring. Sine of theta is opposite over hypotenuse. So this is 5 over 13 squared, which is 25 over 169. The only factors of 25 are 5 and 5, and 169 is not divisible by 5, but that is our final answer. All right, let's look at another example. We have our right triangle drawn, and we are given cosecant of theta is equal to 13 over 5. Calculate tangent of theta minus 3 secant of theta. Okay, we have our right triangle. This is the opposite side. Across from 90 is our hypotenuse, and next to our angle is adjacent. Cosecant of theta is equal to hypotenuse over opposite. And that's equal to 13 over 5. So let's label our side lengths. The hypotenuse is 13, and the opposite is 5. And now I've practiced 5, 12, 13s enough to know if my hypotenuse is 13, one of my legs is 5, the other leg is 12. So we want to calculate tangent of theta minus 3 times secant of theta. Okay, tangent of theta is opposite over adjacent, minus 3 times secant of theta, which is hypotenuse over adjacent. Opposite is 5, adjacent is 12, minus 3 times hypotenuse is 13, and adjacent is 12. Now, in the 3, 4, 5 video, you may have seen where I simplified the fractions first, but you want to have a little bit of finesse when you're on your standardized test. Right now, my two fractions have the same denominator. If I were to simplify this second fraction with 3 over 12, my fractions will no longer have the same denominator. So that's going to cause more work. So what I'm going to do is just multiply the 3 times 13 over 12, which is 39 over 12, so that I can just subtract my fractions as is without having to go back and find a common denominator. So that's going to be negative 34 over 12. Both are even, so both are divisible by 2. That's negative 17 over 6. I know 17 is prime, so I know I can't simplify any further. In this example, we're given a right triangle and 2 of the sides are labeled, and we're asked to calculate tangent of theta. Okay, so let's get our sides labeled. Across from theta is opposite. Next to theta is adjacent, and across from 90 is the hypotenuse. We know tangent of theta is equal to the opposite side divided by the adjacent side. So right now I know my adjacent side, but I don't know my opposite side. I could use the Pythagorean theorem, get my opposite side, and be done with it. But what I do notice is my hypotenuse, which is 26, is a multiple of 13. I recognize this as 13 times 2. So in my other leg, one of my other legs is 5 times 2 or 12 times 2, and this is a similar triangle of a 5, 12, 13. So the leg that I was given is 10, which we know is 5 times 2. So this is a similar triangle of a 5, 12, 13, which means my opposite side is 12 times 2, which is 24. So that means tangent of theta is equal to 24 over 10, which simplifies to 12 over 5. Go.
How does the moon cut its hair?
How?
It eclipses.
In this example, we're given our right triangle, and we are asked to calculate cosine squared theta plus sine squared theta. Let's get our sides labeled. Across from our theta is opposite. Across from 90 is our hypotenuse. And next to our theta is adjacent. Okay, so we have our opposite side, we have our hypotenuse, we don't have our adjacent. We could use the Pythagorean theorem to find it. The numbers are quite large. So let's see if there's a trick we can use. I recognize 39 as 13 times 3. So if one of my legs is 5 times 3 or 12 times 3, this is a similar triangle of a 5, 12, 13. Well, 15 is 5 times 3. So that means my adjacent side is 12 times 3, and 12 times 3 is 36. So now we have all the sides of our triangle, and we can go ahead and calculate what's asked. We rewrite cosine squared theta as cosine theta squared plus sine theta squared. Cosine theta is adjacent over hypotenuse squared. Sine theta is opposite over hypotenuse squared. So 36 over 39 squared plus 15 over 39 squared. Remember, we simplified down before we square because it makes our life a lot easier. So we know this is automatically going to simplify down to 12 over 13. And this is 5 over 13. So that's 144 over 169 plus 25 over 169 equal to 169 over 169, which is 1. Now, if you have a lot of finesse when it comes to trig, you would have known that given any theta, we have the identity cosine squared plus sine squared always equals 1. So that was a cool way to show that that identity is true. But again, the more finesse you have, the more time you save. Let's take a look at our last example with our special guest 5, 12, 13. Okay, we're given a right triangle and the hypotenuse is 39. So a right triangle is shown, and it is known that cosine of theta is equal to 5 over 13. Calculate tangent of theta minus 5 times sine of theta. Okay, like normal, let's get our triangle labeled. Across from 90 is our hypotenuse. Across from theta is opposite. Next to theta is adjacent. We're also given that cosine of theta is equal to 5 over 13. And we know cosine is adjacent over hypotenuse. Okay, right now our hypotenuse is labeled 13, which means we know cosine of theta was simplified down. And we know 39 is 13 times 3. Our leg, or our adjacent leg, simplified down to 5. So our hypotenuse is a multiple of 13, and our adjacent side also is a multiple of 5. So that lets us know this is a 5, 12, 13. So our adjacent side must be 5 times 3, and that means our opposite side is 12 times 3. So this is 15, and this is 36. We need to calculate tangent of theta minus 5 sine of theta. Tangent of theta is opposite over adjacent. Sine of theta is opposite over hypotenuse. So we have 36 over 15 minus 5 times 36 over 39. So we have 12 over 5 minus 5 times 12 over 13. So that's going to be 12 over 5 minus 60 over 13. I'm going to crisscross and across. Criss, cross, cross. So I'm going to have 12 times 13 minus 5 times 60 all over 5 times 13. Which is going to be negative 144 over 65.